Alright, so in this video, I'm going to be solving the problem 100 to the power of x is equal to 10 to the power of x plus 1 to the power of x. So, to solve this, what I'm first going to do is rewrite 100 to the power of x as 10 squared to the power of x. So now this is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 10 to the power of 2 to the power of x is equal to 10 to the power of x to the power of 2. So now I have 10 to the power of x to the power of 2 is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form, 1 to the power of any number is just going to be 1. So we can just get rid of this x as an exponent because it won't really change anything. So now I have 10 to the power of x squared is equal to 10 to the power of x plus 1. And now from here, I'm going to let 10 to the power of x equal to the variable m. So now I have m squared is equal to m plus 1. And this turns into m squared minus m minus 1 is equal to 0. Now I'm going to use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get m is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4a which is 1 times c, which is negative 1, all over 2a, so 2 times 1. And this turns into positive 1 plus or minus the square root of plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So this is the value of m. And to be precise, the two values of m are 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. Now, remember how we let m equal 10 to the power of x. So 10 to the power of x is equal to 1 plus the square root of 5 over 2, and 10 to the power of x is also equal to 1 minus the square root of 5 over 2. So for my second equation over here, 10 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5 over 2 is a negative number. And you can't take the power of a positive number and make it equal negative, meaning there's no solution to this equation. So we are only left with 10 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I get log 10 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move the exponent b to the front, so this turns into b times log a. So now I have log 10 to the power of x, which I can move x to the front, so I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. And now I'm going to divide both sides by log 10. So then these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. And log 10, if you guys already know, is equal to 1. So this turns into log of 1 plus the square root of 5 over 2 over 1, which is the same thing as log of 1 plus the square root of 5 over 2. There's no need to include the over 1 because anything over 1 is itself. So this is my solution to this equation. Alright, so in this problem, I have x to the power of 9 plus x to the power of 6 is equal to 36. So to solve this, I'm going to first start by rewriting this as x to the power of 3 times 3 plus x to the power of 3 times 2 is equal to 36. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 3 is going to equal x to the power of 3 to the power of 3, and x to the power of 3 times 2 is going to equal x to the power of 3 to the power of 2. Now I'm going to let x to the power of 3 equal to the variable y. So if I substitute in y for x to the power of 3, I get y to the power of 3 plus y squared is equal to 36. And if I subtract 36 on both sides, I get y to the power of 3 plus y squared minus 36 is equal to 0. So to solve equations like these, we actually have to first find one solution to that equation and then use that one solution to find the remaining solutions. So how are we going to find that first solution? Well, the only way to actually do that is to just plug in values and see if they work. So we're going to first plug in x equals 1, and if x equals 1, we get 1 to the power of 3 plus 1 squared minus 36, which is equal to 2 minus 36, which does not equal 0. For x equals 2, I get 2 to the power of 3 plus 2 squared minus 36, which is equal to 8 plus 4, which is 12 minus 36, which again does not equal 0. Now I have x equals 3, so I get 3 to the power of 3 plus 3 squared minus 36. 3 to the power of 3 is 27. 27 plus 3 squared is 9, so 27 plus 9 is 36. 36 minus 36 does equal 0, so this is right, and x equals 3 is the solution. So now that I have this should be y equals 3 as a solution. What I have to do is divide y to the power of 3 plus y squared minus 36 with y minus 3. So to divide these two, I'm going to have to use synthetic division. And if you guys don't know what synthetic division is, I recommend watching a video on it. But basically, we have our coefficients of our numerator here. The first coefficient is 1, the second one is 1 as well. We're supposed to have a y here because our exponents go in order, decreasing, and we don't have y to the power of 1 here, so we just say 0. And then finally we have negative 36 at the end. And then our denominator, we have 3. So now we're going to drop down 1. 3 times 1 is 3. 1 plus 3 is 4. 3 times 4 is 12. 0 plus 12 is 12. And 3 times 12 is 36. Negative 36 plus 36 is 0. So I have a remainder of 0. And these are going to be my coefficients for my problem right here. I have x squared plus 4x plus 12. Sorry, this is actually y squared plus 4y plus 12, meaning that this is equal to y squared plus 4y plus 12, and also this means that y minus 3 times y squared plus 4y plus 12 is equal to 0. So now this gives me two equations. I get y minus 3 is equal to 0, meaning y equals 3, and we already know this. And I get y squared plus 4y plus 12 is equal to 0. And to solve this, we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 4, and c is 12. So I get y is equal to negative 4 plus or minus the square root of b squared minus 4ac. B squared is 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 12, all over 2a, so 2 times 1. And this is equal to negative 4 plus or minus the square root of 16 minus 48 over 2, which is equal to negative 4 plus or minus the square root of negative 32 over 2. And this is equal to negative 4 plus or minus the square root of 32 times the square root of negative 1, which is the same thing as I, over 2. And the square root of 32, this can be simplified to the square root of 16 times 2, which is equal to the square root of 16 times the square root of 2, which is equal to 4 root 2. So this is going to equal negative 4 plus or minus 4 root 2 I over 2. And if I divide both of these terms by 2, I get negative 2 plus or minus 2 root 2I. So I have 3 solutions of y. However, we aren't done yet because remember, I let x to the power of 3 equal to y. So I get x to the power of 3 is equal to 3. And I also get x to the power of 3 is equal to an imaginary number, which we actually can't do, so we can't use this equation. So the only solution I can use is y equals 3, and to solve this, I'm going to take the cube root on both sides. The cube root of x to the power of 3 is x, so I get x is equal to the cube root of 3. So this is my solution to this problem. And remember, whenever you're solving problems like these, use synthetic division, so you always have to find one solution first and use that other solution to find the remaining solutions.